So that's what's on our quiz today. It's entire radicals, like that one. Okay? Entire mixed, like this one. Okay? Back and forth. Only it's not, yesterday was all square root. Today is cubed roots, maybe some fourth roots. Okay? So same stuff, just a little more involved. Of course, we're more familiar with square roots than cube roots. Here's a handy dandy table again. Who made note of where that was last time? Well, here it is again. We should be starting to memorize some of these numbers, at least those ones. When you see 64, you got to think to yourself, 4 times 4 times 4, 64. The cubed root of 64 is 4. 64 is a nice number. It's a perfect cube. It's also a perfect square too, isn't it? Yeah. All right, 27. That's a perfect cube because 3 times 3 times 3 is 27. Okay? 3 cubed is 27. All right, so how do we do this? I want to make this entire radical. There's no number out front of it except a 1. Okay? I want to make that a mixed, and they're kind of helping us. You want to find, yesterday, I wanted to find perfect squares. This is cubed root, so I don't want to find a perfect square. I want to find a perfect cube inside 54. What's half of 54? Is 27 a perfect cube? Yeah, because 3 times 3 times 3 is 27. Now we can split it up into the cubed root of 27 times the cubed root of 2. Okay? This is still the cubed root of 54. What's the problem, Taylor? Well, you look far too happy for math class. What is the cubed root of 27? 3. Look, there it is. Okay? Times the cubed root of 2. All right? So, as a mixed radical in simplest form, there it is. I converted it from an entire to a mixed, okay, in simplest form. There's no more perfect cubes in 2. If you can find another one, then you keep going, okay? Can I check to see if that's the same if I have my calculator? Okay, this had better be the same decimal as that, or I did something wrong. I'm not going to plug that in because we got a quiz. All right? Questions at this level will involve simple perfect cubes. Okay, well, you're saying they're not simple. What's he talking about? Well, they could be a lot harder. That's where grade 11 comes in. All right, cubed root. Always got to look here. Right? Might be cubed, might be squared. You got to look there first. I need to find a perfect cube in 6,000. All right? Look on our table. Do you see a number that goes into 6,000? Way down here. Ooh, that would be nice. Let's split that up into the cubed root of 1,000 because I know what that is. That's a perfect cube. And the cubed root of, well, 6,000 divided by 1,000 is 6. And what times what times what is 1,000? 10. Yeah, okay. That's why it's on this list, right? It's a perfect cube. So that's 10 times the cubed root of 6. Let's make that a little clearer. That's more clearer. Why is it always you guys? My pen acts up. Right. Oh, God. All right. Well, that's as good as it's going to get. All right. Oh, my God. Fifth root. What does it mean, fifth root? It means there's a number multiplied by itself 5 times, okay, to give us some other number. All right. Is there a fifth root table here? No. We don't even have a fourth root table. But we have seen this before in some of our other assignment questions. What number multiplied by itself 5 times will give me 32? 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Does that help us? Can I get a 32 out of 320? Well, let's split it up. That's the 5th root of 32 times the 5th root of 10, right? That could be on the quiz. All we're doing is splitting up that entire radical into a product of radicals. And why did I do that? Because I know what this is. I know the 5th root of 32 is 2 times the 5th root of 10. Okay? I'm done. It's fully simplified. It's a mixed radical because I got a number out front, and it's in simplest form. Okay. Can I take the cube root of a negative number? Can I take the 4th root of a negative number? Anybody think they can do that? All right. I need to find a perfect cube in 16. Hey, I got a list of perfect cubes right there. Which one of those goes into 16? Yeah, that does. All right. Now the question is, what do I do with this minus? I want to have this, so if I take that out, then I have that left. Is that the same thing? Can I do that? Yeah. My other option is, well, maybe I can put the minus on the 8 instead, right? They're both right. Okay? But the book will like this way better. I can take the cube root of a negative. What times what is negative 8? Negative 2 times the cube root of 2. Okay? Which they like better than the cube root of positive 8 is just positive 2 times the cube root of negative 2. Okay? They like this one better. Okay? Because our minus isn't in the radical. But I'm going to argue that's still correct. But of course your answer key is not going to have both answers, right? Okay? If we can take the minus out, we're going to take it out of the radical. Okay? Sorry? Well, if you can take the cube root of a negative. But if it's square root, you can't. So you're going to, well, should I come up with an example here? Let's not worry about that. No, I don't want to confuse you. If you can do it, do it. And if you can't, then, well, maybe this just doesn't have an answer at all. Right? Like that. Okay? Yeah. Okay? So that's going from entire to mixed. We also got to go the other way around. We got to go from mixed to entire. And they're going to give us a nasty one right off the bat. I got a fraction. Everybody loves fractions, right? So remember, if I'm going to do this, yesterday we said that's a mixed. I want to make it an entire. I don't want this number out front. I want to tuck it under the radical sign. So you need to ask yourself, 2 is the same as the square root of what? It is 4, right? Let's just write that like this. 2 is the same as the square root of 4, and root 3 is just root 3. And if we take this product of radicals and make one radical, that's on your quiz, all I do is multiply it. Okay? It was mixed. Now it's an entire. It's the same number. It's going to make the same decimal on your calculator. All I'm doing is converting it. Okay? So that's how we did that. We're doing exactly the same thing, only it's cubed roots. 1/2 is the same as the cubed root of what? The cubed root of 1/8 is 1/2. Because 1/2 times 1/2 times 1/2 is 1/8. Okay? Like I said, I'm sorry the first example is a fraction, but that's how my book is. Now I got cubed root of that times cubed root of 80. I can join these. And what's 1/8 of 80? 8 goes into 80 10 times. 1 times 10 is 10. Okay. That looks a lot nicer than this thing. Okay, just a couple more. Convert these mixed to entire. I know it's mixed because I got a number out front. So you have to ask yourself, 2 is the same as, I'm talking 4th roots here, right? Who knows this one? The 4th root of a what is 2? It is 16. Now, if we see that, great. But how do you get it if you can't see it? Because you guys are new at this. You haven't really got too many of these memorized. Here's a little trick. I want the 4th root of whatever this thing is to the 4th power. Is this the same as 2? Well, is the square root of c squared, when you guys did Pythagoras, is that equal to c? Yeah. This kind of cancels this out. Guess what the cubed root of x to the 3rd power is? Yeah. Guess what the 4th root of 2 to the 4th power is? Yeah. And let's think of it this way. Well, what's the 4th root? What is 2 to the 4th power? 2 times 2 is 4, times 2 is 8, times 2 is 16. What number multiplied by itself 4 times is 16? It is 2. So it's up to you. What way do you want to think of this? The 4th root of what is 2? That's the 4th root of 16. But if you don't know that well, just write the 4th root of 2 to the 4th power. Because these kind of like cancel out. It's not really accurate. Like a math professor would get mad I was saying that. But I just want to make sure you guys get the same mark. And this is 2. It's the same as that. Okay? Times, I still have the 4th root of 3. Now I can join them. That's the 4th root of 16 times 3 is 48. Let's just check that one, because I'm really confused. 2 times the 4th root of 3, that's what this is 2.63. So that better be the same as this, right? 4th root of 48. Aha. I know I got it right. It's the same number. All I'm doing is converting it from a mixed to an entire. There's no number in front of this, right? It's just a 1. 1 times the 4th root of 48. Yeah. Your quiz?
No,
Yes. Sure. Why not? Are those radicals? Are you taking, when we do Pythagoras, are you going to take the square root of that? Yes, you are. That's a radical? Sure. Could be. I'm not saying for sure, but it's fair game. Yep, you bet. All right. Cube root. Okay, that's a little nicer than 4th root. This one we should be getting to memorize. All right. The cubed root of what is, let's just look at the positive part, 4. Cube root of what is 4? 64, you all yell out in unison. Yes, that's right. Okay, 4 times 4 times 4 is 64. Can I put that negative here? Is that fine? Negative 4 times negative 4 is positive 16 times another negative 4 is negative 64. Okay, this is the same as -4. I've now made it a cubed root instead of a number. Still have times cube root of 7. So all I have to do is join those, okay? You know what? Whatever that is, that's the answer, okay? 420, 448, negative, okay, whatever. That's what it is. Let's skip the fraction right now. Let's go to this. -3. I need the 4th root of something that equals -3. Is that possible? What this is. Okay. 3 times 3 times 3 times 3 is 81. Again, if we don't see that, do this. 4th root of 3 to the 4th power is 3. But now I got my negative. Okay? This, guys, is -3, right? It's the same number. But now it's in radical form, so I can join it to this 4th root 2. So I have negative, let's join them. This is 3 times 3 is 9, times 3 times 3 is 9, times 9 is 81, times 2. Okay? That's as hard as they're going to get in the test, right? And like, don't think like half my test is going to be this stuff, because I see lots of you guys look like deer in headlights. Okay? No, it's going to be like maybe 3 questions, okay, on a test of maybe 25. All right? So don't freak out. Is that the door? Hello? Yes. Yes, it is 2 o'clock, isn't it? You guys can do your quiz when you get back. Alicia, and who else? Matt and are you going too? Okay, you're just going to miss the last little bit.
You guys want to wait for you to stay for a little bit if you need to, if it's really important, come when you're done.
5 minutes would be perfect.
That would be perfect.
Okay, you can just finish this. You do the quiz when you get back. I just got 5 minutes.
Just those 2. No, Tyrell too. Please, Tyrell. Huh? Come talk to me about anything. Okay?
Okay, sorry. This says extension. I'm just going to give you a couple of questions like this. There's no number here. That doesn't mean we can't do it. What am I doing? I'm converting this entire radical to a mixed radical. There's no number in front. I got to put a number in front. Oh, wait a minute. There's no number here at all. Can I still do this? What do I do here again? I need to find a perfect square. That's how I do these, right? Because then it makes it mixed in simplest form. What's the perfect square in a to the 7th power? Well, is this the same as that? That could be on your quiz. Is that the same? Yeah. Okay. And I know we haven't done exponents yet. We're getting there, but this you saw in grade 9. If you have the same base, you multiply by adding the exponents. 6 and 1 is 7. So that's the same as that. So, square root. Again, it's not just, yay, root 16 is 4. You got to understand what it means. There's a number multiplied by itself to give you 16. That number is 4. Is there something multiplied by itself to give us a to the 6th power? Anybody? Chloe? 1? Not 1. What is A3 times A3? Multiply, same base, add the exponents. What's 3 plus 3? Yeah, is the square root of a to the 6, a to the 3? Yeah. So this thing, the square root of that is a3 times root a. That's a mixed radical. It's not all under the radical sign, and it's in simplest form. I can't find another perfect square in a. Okay, I know that's looking like Latin, not English, not math, okay? But at some point in your lives, you're going to have to digest this. I'll just start now. Okay? All right. How many more of these do I want to do? Let me just do this one. Well, let me just do this one. Cubed root. All right. What times what times what? I need to find a perfect cube in there. What do I want to split up x to the 5th into so I can take the cube root of it? Cube root of, is that the same thing? If I multiply these, I get that, yeah. And is there a number multiplied by itself 3 times to give me x cubed? Yes, it's x times the cubed root of x squared. Okay? So again, on the test, maybe 1 or 2 questions like this, okay? I know it's pretty abstract. All right? Last one. Now it's a mix. I need to make it an entire. I need to take this 2 and stuff it under the radical sign. Well, we've done this. The square root of what is 2? Okay, these ones are actually easier, aren't they? I don't even have to worry about that x cubed there. Okay? Okay, so 1, just ABC. 2, just ABC. All of 4. 8, ABC. Not 9. 10, ABC. And 11. That's today's stuff. I will give you a little bit of what we're going to do Monday in case you want to get a head start on the weekend. But if not, I'll give it to you Monday. But what kind of a mark do you want? If you want a good one, you're going to want to do everything I give you, right? If done, start. This is page. In the book, we have some review questions. All right. 1 to 14, but not 4, 8, and 9. So that's the whole chapter. They're going to start easy, right? They're just going to be prime factorization, and they're going to get to this stuff. Okay?